morning. Thank you for joining us for the Team Research Forum this Friday. We were in a little bit of a break. We didn't have as many Team Research Forum last year, but this winter and spring, we have a nice program set up for you. This is the first session. If you want to learn more about the Team Research Forum and some of the events that have taken place in the past and some of the events we have lined up for this quarter and next quarter, please go to our webpage. One of my colleagues will post it in the chat box. I want to thank Associate Professors Gözde Gronsberg and Katia Vega for joining us today for this session on wearable technologies. We tried to make this a fairly casual, informal conversation to highlight some of the really interesting and cutting-edge research happening on campus, and hopefully help you make some new connections and imagine some possibilities for your research program. Professor Gözde Gronsberg is Associate Professor in Design here at UC Davis, and her lab is Wearable. I think we have a link to her research program coming up on the chat box if you want to learn more about it. But she focuses on human-centered design of textile-based wearable products for people with special needs. Associate Professor Katia Vega is also with the Department of Design. Her work is focused on beauty technology, merging electronics with cosmetics, but also body modification technologies, incorporating biosensors into tattoos, and dental orthodontics for sensing. Her lab is called the Interactive Organisms Lab, and I think we have a link to her research program also on the chat box. With that, I am going to let them give us a tour of all of this incredible research. I'm very excited for this session, and I think we're going to start with Gözde.
Okay, let me share my screen. Okay, so when I do this, do you also see all the notifications from the Zoom?
No, I just see your screen.
Okay, perfect. So I guess I can go ahead and get started.
Gözde, do you want to switch it to like full screen mode, or are you going to keep it like this?
I'd like to we could do with a full screen. Is this better?
Yes, thank you.
Okay, you're welcome. Hi, good morning, everyone. My name is Gözde Gronsberg. Probably the hardest thing you're going to hear today. I am going to be talking about wearables from the perspective of textiles and clothing, a different medium than what Katia will probably introduce to you. I have a website for my lab, wearlab.ucdavis.edu. It's pretty outdated, but still will give you some ideas about the things I do. So here's a little bit of background information about me. I combine multiple fields in my education. I have a background in industrial design, product design, as well as clothing design and textile engineering, mainly from Istanbul Technical University in Turkey. Then I've done all this back and forth between the continents. I got my PhD in design at University of Minnesota, and I've been here at UC Davis since 2018 as an associate professor of design. I've already talked about the lab a little bit, and Anna did a brief introduction. As I said earlier, it's mostly focused on the wearable technology using the material textiles and forming them into interactive garments for a variety of reasons, but majority of my focus is healthcare applications. I also experiment a lot with different digital fabrication technologies like 3D printing, to explore other ways e-textiles can be created. So I'm just going to start with some basic definitions of what the wearable technology is. It's basically electronics worn on the body for extended period of time, either on the bare skin or on top of the clothing. The common product categories for wearable technology, as you all know, include things like smartwatches, fitness trackers, and also things that are not necessarily worn on the wrist. There are a few examples of smart jewelry and smart glasses out there. Although there are all these other forms, majority of the commercial value for wearable technology so far came from products that are worn on the wrist. But as humans, we only have 2 arms, and most people would probably wear no more than 1 or maybe 2 items on each wrist. And wearables market is already filled with bracelets, wristbands, smartwatches that offer a wide variety of functionalities. So introducing yet another bracelet, even if it does offer a new functionality, would need to directly compete on the same limited body space that is already occupied by a large set of existing wearables and bracelets. So that takes me to this very important platform for wearable technology, clothing. So there are many definitions of clothing out there. Some of these definitions refer to clothing as the closest objects to our skin, therefore our second skin. Clothing is also referred as microenvironment that can protect us from external influences, and also extensions of the body, extending our capabilities, such as in the case of wearing a spacesuit. So since this microenvironment, clothing is something present and held close to the body unless we forget to wear them, they're a great platform to sense and monitor the body and interact with the environment. Embedding sensor technology in clothing opens up a new window into the objectives and the needs of the human inside, as well as provides opportunities to interact with the environment. So smart clothing is distinguished from other worn wearable accessories like bracelets and watches that come in some, and the smart clothing come in some form of a clothing item that is interactive. And what makes them so special is that they are physically proximal, they're close to the body, they are socially ubiquitous, and they're also worn almost all the time. And they also have a large surface area, which allows for easy access to different parts of the body for monitoring purposes or for interaction purposes. So far, there are a few commercially successful smart clothing products out there. Hexoskin is one of them. I believe it's a Canadian company. They are able to do hospital-grade ECG monitoring with their shirts, and they collaborate a lot with medical professionals. You should be able to find a lot of publications done by medical field using the Hexoskin. So next, electronic textiles or e-textiles. You heard me using that terminology already. These are textiles with embedded electronic functions that can be at the fiber level, yarn level, or fabric level, and they can function as sensors or actuators sometimes. The main methods, the main materials I use are conductive yarns and conductive fabric, sometimes conductive inks, and the way I integrate them on smart clothing applications are through really well-known techniques like embroidery, weaving, knitting, and printing. Another fun thing about wearables in the form of clothing is interaction with them is quite different in terms of providing the input. For things like smartwatches, usually the input is through interacting with a screen or pushing a button. But when we take this wearable interaction into a soft clothing form, closures like Velcros or buckles or zippers or snaps, or even touching the fingers together could become input devices that are very natural. For example, think of like zipping up a jacket could bring the temperature of a smart garment higher because, you know, it indicates that type of a movement. So there are lots of possibilities of really novel ways of interacting with smart clothing. The wearable input can also be implicit through the sensors, and there are many ways of creating soft textile-based sensors, including anything from EEG, ECG, to galvanic skin response, gait, weight distribution, skin hydration and firmness, temperature. There are, again, a few commercially available smart clothing in the market. The Owlet baby monitor is one of them. You can track baby's heart rate through this little booty. And Sensoria is a sock with embedded, I think it's knitted. It's embedded in the knit of the socks. And there are pressure sensors under the sole, and it can provide you with gait analysis. And wearable output also is very useful, right? We are so used to seeing only monitoring side of things, mostly with bracelets. But with smart clothing, you have a lot more chances to provide different outputs. For example, with heated jackets, the output of the system is heat. Here is an example from a company called Natty X yoga pants. These smart yoga pants have vibration motors integrated into them, along with probably accelerometers and gyroscopes. And they can, through vibrations, they can guide you into yoga poses. So from here, I'm going to jump into my own research, and my research really combines implicit input and creates a novel output for the wearer. The first project I'd like to introduce is CalmWear. If you scan the QR code here, you'll be able to see it in action. There's a little video. This garment provides a unique user experience with reactive compression and tactile actuation via an inflatable bladder at the back of the vest here, as you can see. Vital signs of HRV and respiration rate are monitored through the embroidered ECG electrodes and a conductive rubber cord stretch sensor. We have a prototype of a detachable custom-built hardware at the back pocket of the vest. So in here, we carry the PCB, a mini air pump, and a pressure sensor to regulate the compression, and a solenoid valve and a battery. So moving on, if I can. Why am I not in the presenter mode? Okay. Here you can see a little bit more description about the actuating portion of the garment. There is a pneumatic actuation opportunity through a bladder we designed that sits on the back of the vests and kind of like hugs the body towards the sides and towards the shoulder. So CalmWear provides compression and this tactile sensation with a single inflatable bladder. And it is strategically textured so that it allows for comfortable movement. It's not restrictive in the compressive state. This is a snapshot of the e-textile sensing system that was integrated into the vest. We use a 2-lead ECG to monitor HRV. And then about here under the armhole, we have a stretch sensor that we use to monitor respiration rates. And all the connections are done with conductive threads, as you can see here. And we use snaps to connect the hardware to this soft system. The second project is Privy. Again, I have a QR code so that you can watch Privy in action. So this is a wearable undergarment that monitors bladder fullness non-invasively without the need for catheterization using bioimpedance spectroscopy technology. So what you see here is the working prototype with all the PCB attached to it. And I think in the next slide, I have the e-textile sensing system. So in the inside, this is what the garment looks like. The garment has 8 textile electrodes along the waist, around the bladder region. And we use the bioimpedance spectroscopy technology and assess the bladder fullness by analyzing the electrical properties of the bladder fluids. And all the electrodes and the textile transmission lines are seamlessly integrated into the fabric. The only hard component here is our novel PCB board that we developed only for this garment. So I have many other interests too. I just shared two of the interesting latest projects with you here. Lately, I'm also interested in 3D printing for e-textile sensor applications. So here is a 3D printed stretch sensor with the auxiliary pattern. And then you can see it in action. So it reacts by changing its resistance as it's stretched. So these are some early trials for this sensor. I'm also very interested in shape memory alloys and exploring the dynamic tactile stimulation through kinetic textiles. So I have some tiny little videos which will show you how they can work with textiles. I am very interested in further exploring shape memory alloys with the goal to create tactile stimulation that can be used in rehabilitation as a calming effect or as a sensory stimulation. In these two QR codes, I have more fun examples of what I did with the shape memory alloys. These are more like interactive fashion projects. Again, if you scan them, you can see them in action as well. So that brings me to my last QR code scanning for you. I'm organizing together with colleagues at Royal College of Art in London a symposium that's dedicated to wearable research. It's called Wearables Collective, and it's going to be held here in UC Davis at the Design Department Makerspace, March 25th and 26th. Currently, our registration is open. If you have or your students have any exciting papers, either full papers or short papers of ongoing work, or even prototypes that they want to showcase, I highly encourage that they submit. The deadline is today. That's the bad news. But the good news is I think we can be flexible for our internal submissions. Registration for the conference is also open. Right now, we can only do the registration with credit card. But if you'd like to use your university account, we are looking into possibilities of making that happen. My department is working on understanding this new system. Once we have that understanding, we'll have a better way of describing what we need from us. But for now, if you would like to register using an UC Davis account, maybe directly reach out to me. I'm going to show my email address at the last slide one more time. Yeah, reach out to me with your name and the account number. Then we'll be in touch with you from there. But if it's a credit card, it's just through the link. And then we have some very exciting keynote speakers. We have Jean Tan from Hong Kong Polytechnic. She is the director of the Laboratory of Artificial Intelligence in Design, and she's going to give a talk on intuitive surfaces with artificial intelligence and knitted textiles. Next, we have Laura Davendorf, assistant professor at the Atlas Institute and Department of Information Science at University of Colorado Boulder. And she directs the Unstable Design Lab there. And she's going to talk about weaving and counterfactual narratives of technical progress. And the final keynote speaker is Cindy Hee-Sin Lee Kao from Cornell University, director of the Hybrid Body Lab. And she's going to talk about designing hybrid skins. So it's going to be a highly interdisciplinary symposium. If you'd like to hear more and learn more about wearable technologies, I just wanted to share this opportunity. And then after this introduction and showing my email address in case you need to reach out to me over here, I will pass it to my amazing colleague, Katia Vega. So.
Hey, thank you. And let me see. Let me know if you cannot see my screen. But yeah, it's a pleasure to be with you guys today. Amazing to be together next to Gosle and see all the great work her lab is making here. Also, we're kind of neighbors in the Department of Design. We're kind of like working in similar fields in wearable technology. So I'm very happy to be also sharing with you the research we're doing in my lab, that is the Interactive Organisms Lab, and guide you a little bit on my research and probably a little bit about my history. My name is Katia Vega, I'm Associate Professor at the Department of Design. Also, I'm part of the graduate group in computer science. My background is in computer science. I am from Peru. That's where I study. And after that, I went to Brazil to go to do a master and then also a PhD, also in computer science. When I was doing my PhD, I had this great opportunity to go to Hong Kong, but not to a computer science department. It was an art department. And I think that that's kind of like very different from all my other classmates. So I thought that I was kind of like having this great opportunity to be exposure to other ways to create. And right now, and even you will see in some of the projects, I follow that approach of using art as a way to expose novel technologies and to also make it accessible also for other kind of audience, these new technologies that we create. Finishing my PhD, I did a postdoc at MIT Media Lab, where I also had this great opportunity to think about also novel ways to blur the lines between technology and the skin. That is the research I will be showing mainly today to you. And after that, now I'm here at the Department of Science since 2017. Now I'm an associate professor, and I lead this lab that is an interactive organisms lab that we think about how to make invisible information visible from our body. So you could think about a gesture like blinking, or even information that is in your saliva, how we could blur those lines and make it ourselves or our skin like as an interactive platform. And this lead us to think, I will lead you to think a lot on the skin itself. And if you think about a skin, it kind of like give us this property, or you touch something, you know its properties, something is hot or cold, your skin changes color, it gives you information about what something is going on with your body, physical or psychologically. And our skin is also this platform expression. And makeup is one of these options that we have to create those expressions. And if you think about makeup, it didn't change very much over the time. You know, like I have a realistic, my mom had a realistic, my grandma had a realistic. And when I was doing, this was mainly my PhD project, I was thinking about how we could actually give another functionality to cosmetics. So I came up with this concept called beauty technology, on how we could embed into cosmetics electronics. So you could think about eyelashes that you blink and turn lights, or hair that you touch the hair, send a message to the police, for example, or fingernails that you touch something and you could pay the metro with your fingernail. This is, for example, this is one example of a second skin that has gestures as a platform, like blinking, smiling, closing the lips, that how this could create, in this case, lighting patterns in an output that is this form of an artistic video that we create. This video actually was inspired in Felipe. The Felipe was 6-time Brazilian championship in Jiu-Jitsu. And during one training, he had an accident. So now he cannot move his body. And I had a project that was these eyelashes that you blink and make a drone to fly, kind of like a superhero. And he said to me, like, I would like to be a superhero. I would like to have this superpower of blinking and changing the channel that sometimes for me is probably 30 minutes of the time waiting for someone to come to me. So we work together in this, it's kind of like a skin platform and detecting kind of like it's blinking for turning on and off the TV. So I just kind of like let you narrate this to show you how an artistic exploration could also be expanded to think about other limits of technology now apply to probably disabilities or other aspects of human life. And if we think about our body, we could also think about our hair. And this project is called Hair Wear. We use a chemical process for metallizing these hair extensions. So every time we touch one of these hair strings, we could send a message, in this case, by using Bluetooth through a device. And this project can lead us to also think about different applications. Like, for example, you could just touch your hair and just send a message that it was already predefined. And maybe a little more controversial to think about how we could use like a secret agent that could be recording a conversation just by touching touching the hair. Or even if we think about someone that is in a risky situation, you don't want to take out your phone to send a message to the police or your family, you could just touch your hair and send that message. And of course, take a selfie could be much more fun. And that's for me something, and I'll show you these applications to show you, like, for me, it's very important to think about the technology itself that we create instead of like a specific application or solution, to think about how this new technology could have different possibilities. If we think about our body, we could also think about our fingernails. This case, we have these RFID nails, RFIDs that are embedded into these fake nails. In this case, we could see that this is kind of like in the air. We could play the piano. Each fingernail is a different music note or yeah, like a different tone. And I like this idea because then we could imagine this same application. I explore in different ways, you know, like if every card that you have, for example, in your wallet, that you could pay Starbucks or open the door of your office or your lab, what if each of them could be actually in your fingertip? And these are just some examples of different examples that we create, and we embedded all of them in this book called Beauty Technology. Actually, here at this series, we're expanding with other projects related to that. And it's a way to kind of like think about wearables, but instead of thinking about clothing or accessories, going even a little bit closer and putting that directly on the skin or its appendages. So how our skin, this 2-meter square of surface that we have around us, could actually be an interactive platform. And for me, it was very excited to think about what could be next. And I was thinking that I was creating kind of like very focused on electronics And it's basically objects, physical objects that are connected in different ways with different also fields, since computer science, electronics, also think about design, also think about art. At MIT Media Lab, they usually call this intersection antidisciplinary concept of how we could actually put a kind of like a hat of as a different role to create something that is not in your limits, or it doesn't belong to a specific discipline. So when I was doing my postdoc at MIT Media Lab, I was thinking, okay, what I will be thinking next. And I was thinking, instead of thinking an object, I would like to thinking about an organism that it also could embed technology. So it led me to think in, or to work in now with biotechnology and biosensors. And now my research lab is more focused in the idea of thinking in body modification technologies, where we still think about or work with wearable technologies, but we are now including body fluids, or including material design, and also biotechnology. You can see over here, oh, they were kind of like coming out too fast, different of these examples, like colorimetric biosensor, fluorescent biosensor, electrochemical biosensors. That was something totally new for us. And to be honest, like a lot of the things you will see, and you probably saw from before, for me, it always involved this exploration of something that I had not, I had no idea how it works, and I will look into that. And they are usually created in research labs that are more scientific or engineer. And I feel like kind of like how we can put it that more closer to humans. And the idea also to use the material itself and just to study and to rethink the way to actually to be used and to be safe, to reversibility, sustainability of the material were also important for us. So it led us to think about these fluids that it has already different kind of properties like pH, cortisol, lactate. So all these different information that we are already having and carrying out with us, how we could actually make it visible. And for me, it was to think about the skin as a whole display and how our self of our skin could actually become a platform or a pixel screen. And we created this project called the Dermal Abyss. And the Dermal Abyss was a mixture of like how to make tattoos met biotechnology by using tattoo inks that could be replaced by this other liquid that is a biosensor that could change its color depending on which analyte it goes in contact with. So for example, if someone have diabetes and it has this tattoo that the inks are different, like these magic biosensors, they are kind of like changing its color depending on the glucose levels. So the glucose levels go up and down and could go from a purple to a pink color. And the main idea of that was to think about how all this information could be visible. And we use tattoos as these artist practice that already exist to have a closer interaction with, in this case, the interstitial fluid. So it goes into the dermis and we could make these connections. Of course, this is a simulation. I cannot make a tattoo to you right now, but it gives us this possibility to, and right now there are other research labs more focused in biotechnology that are expanding this concept to think or to create these tattoos that are actually responding and evolving. And we have also some research that are ongoing on these projects. How they look, they could look like the very first two ones, like this sodium or pH that could change its fluorescence, or we could think about it change its color, like this glucose or colorimetric pH. We also use different ways to sense color. like this colorimetric metabolic detection. We were using a smartphone camera. And also interesting thing about these colors, similar to tattoos that already exist, that it also like the same tattoo could have a different colors already. We could have each color a different analyte. So we could see, for example, one yellow tattoo could be pH, a green tattoo could be glucose, and a blue tattoo could be albumin. And this is particularly helpful for a specific illness that it doesn't involve just one analyte, so it could be involving different ones. And the applications after we released this project, it was actually a lot in the media. We got a lot of feedback from people that I wasn't even imagining that they would like to use tattoos. For example, there was this person that even he said to us, I'm elderly, but I have been pinching myself 10 times a day for 40 years. So I would like that tattoo to tell me that information. Or a father with a 2-year-old girl saying that I need to have a way to communicate with them. Other ones to think about animals or NASA. Like, it was very interesting to see how a tattoo could also expand its possibilities also of application. We also could think about saliva as a vehicle of information. And it's very interesting because saliva is transparent and it constantly is regenerating, and it has a very complex composition. That composition, it involves these analytes, this information that we could actually sense. We create these ligatures for dental braces that they have a specific color, and it could change depending of when it goes in contact with the saliva. This project it's called Brace.io, and we collaborate with, well, my student, Aldi Lazaro, and Ali Jettinson from Imperial College of London, and we were creating different kind of also biosensors, so nitric oxide, pH, uric acid, to also have an app that allows us to get this information. Like you can see over here, how the colors look, and also our fabrication process involve a way that we could have these ligatures actually flexible to mimic like a very similar characteristic of a normal ligature that it has. If we think about fluids, we also have sweat. And sweat, it all different than, for example, the tattoo project. I was also interested in creating devices that are not as invasive as by using a tattoo gun, for example. So we were thinking of how we could sample that through sweat. And there are many examples already that already exist on that. Our exploration was to create this necklace that could sense this biological data. We were focusing mainly in sodium. And this is also a project that was created by my lab in collaboration with Professor Erin Secker from the Department of Engineer, that we were creating now electrochemical biosensors. Instead of changing color, now we could have these electrodes that could sense sweat and could give us that information. And you could see, for example, this as an example of how these electrodes we fabricate itself. And we were using a do-it-yourself practice to also share this possibility and make it also more available for anyone that would like to reuse these techniques. As another exploration of electrodes and electrochemical biosensors, these electrodes. So now, instead of having color, now we have electronics, as I said. But if you see like traditional of these electrodes, as this picture, as this image on the left side, are kind of a square, have like a film. Some of them come on a film like a tattoo shape. And we wanted to kind of transfer its form factor to have jewelry. And that's why we move it to have this kind of like jewelry device that move each of these part of the electrodes and could be actually placed or replace also for reuse it. So each of these electrodes, you could take it out and you could use it as a, for example, as an earring. So you don't waste that electrode that we were actually particularly interested in. So this leads us to think about what it means to have body modification techniques. And I'm particularly interested in including these biosensors in these techniques. It's a way to think about your skin as a display, to have technology that is indistinguishable from the human body, so you cannot see it. And instead of thinking a button or a physical movement as an input, the metabolism in this case is the input, and where our form factor are body modifications. And just to give you a couple more of examples of new projects that we are developing, also with the Department of Engineer and the vet school, we are moving these technologies to animals to sense in diabetics or also in sodium. We could analyze these with these biosensors in urine, different kind of information. And other kind of exploration that we have with wearables very briefly is to think about how we could have a sustainable material. In this case, is a material that it is a mycelium, so it could be embedded and could use it as a substrate for electronics because of its heat resistance and waterproof properties. So we are also rethinking about the way we interact with devices or we create in our own practice as designers. And I just want to thank my lab members, Shuji-san, Howard-ku, and Nicole Dushina, because they are great. The main reason how we could keep all this research going. And I'm very happy to be here. So if you have any questions, please let me know. Suggestions, or I'm very open also to new collaborations. So happy to hear your questions. Thank you so much.
I think everyone can agree that this has been fascinating. We would love to entertain questions from the audience. I want to start by asking you, who do you usually collaborate on campus? Who are the groups that you collaborate with? Because the work looks very transdisciplinary, and I just want to get an idea of who do you work with and who would you like to work with that you haven't, what is that connection you haven't been able to make yet? Maybe Gözde can start. You're muted.
Oh, and I forgot all this, screen talking. Okay, so since my work has a lot of medical side to it, I'm always open to collaboration with UC Davis Health. And it has an engineering aspect, so I collaborate with colleagues at the ECE department frequently. And then I have some collaborators outside of the US, ongoing collaborations in London with Royal College of Art, with a material scientist there, and also collaborators in Turkey, from medical school in Turkey there. Yeah, it's almost sometimes feels like all over the place, and I orchestrate who needs to talk with who for what reason, because the subject is so not necessarily within their specific field. So I kind of like decide now is the time to bring the designer in. Now call the engineer. So that's how, yeah, my projects work.
Katya?
Yeah, I will agree that it's always all over the place since engineer, scientists, designers, and of course artists too. So I think that we are always very open to new collaborations. A lot of the projects we do, as I mentioned, like artists can become a great part of it. Collaborators in campus, I could see Erin Sticker join us today. Has an important role from his engineer background with biosensors. We collaborate with the vet department, with other fields also of engineering, the computer science department with Professor Chuan Huang. And again, I'm very open to collaborate with the medical department a little more. I think that I wasn't collaborated probably enough or as I wish. I want to expand this research to other fields too, even with different kind of applications in psychology view, but also medical applications in general. Yes. But I
Great.
can
We have a
see
question
someone.
from Professor Roslyn Isroff.
It's not so much a question, but you were talking about collaborations. I tuned in. I had another meeting. I tuned in only for Katja's part of the talk, and I'm a dermatologist and chief of dermatology at the VA. We would be very interested in, since you're looking at skin sensors, very interested in seeing if your skin sensors can sense changes in wounds. Wound healing is a big problem, and the VA has technology grants to try and address this. And I can also see many cosmetic applications for the cosmetic industry that tries to remove wrinkles. If you could image the wrinkles and give a feedback to the person who's using the Botox or fillers or whatever they're doing, I think you'd have a great area for expansion as well.
Yeah, thank you. I think that that's kind of like a great idea. Those all are great ideas. And that's something that I think that I had like a little collaboration with dermatologists, basically more to evaluate if a project is safe, for example, for putting on our user studies. But I would like to be expanding to, as I love the idea of the wound. I think that I even had like a proposal ready for having something like that. But yeah, I will definitely get your contact and reach to you. So I would love to keep up this conversation. Thank you.
Any other questions from the audience? I'm really interested in how you go about prototyping. Is that all done on campus, or do you have like, is your lab specially equipped? Is there like limitations around what you can do based on access to prototyping facilities?
I can go first, I guess. Yeah, so all the prototypes are done here in the lab. We have all the technology, machinery that we need to be able to prototype. And I think that gives us a lot of flexibility in terms of, going through trial and error very easily instead of relying to an outside place to get the prototypes done. And then we experiment with a lot of different materials. Again, that experimentation element requires a lot of prototyping and then, furthering that prototype with more prototyping. So we are able to do all of that here on campus in the lab. What I'm lacking is mostly the testing portion of things. Because I end up with these functional prototypes, and I could do some testing in terms of electrical characterization, mechanical characterization, but any testing like clinical trials, things like that, I'd be very, very interested in collaborating on that end with medical professionals.
Katya?
Yes, I will agree that at least our lab, we are always trying to probably democratize the how we create electronics or devices in general. So we like to share, we always try to share our fabrication process. So we try to make as much as possible with things that are available for everyone and make and share it. So we have in the lab most of the material and equipment. There are some portions of that, just as an example, with our collaborator in the vet department, when we want to compare the urine from the cats, specific data, they have specific facilities that they get those analysis, and we kind of like separate that, and so we have our own analysis in our lab. So some part of it is going to other labs, but mostly I would say we develop it here. Yes, and definitely open to more like clinical trials is something that we didn't do in our research. But as here, I could see there are probably more interest in moving that into in probably your own patients or other kind of applications. I could see that as a new possibility. Other things that I think are interesting to see that UC Davis give us is like those connections and collaborations give us these other labs or facilities. For example, here in the Department of Design, there is also the Lighting Center. We are creating now, for example, projects with machine learning and a biosensor lipstick. So we could create different light conditions for that to increase our data sets. So but yeah, definitely open to new ideas. But for now, we are also making it possible and making it open for anyone that wants to create these ideas too. Even the book that we have, we like to share every details in what we get and how everything was created to be possible for other people to replicate. And probably that's why there are some startups actually that they were created with the ideas we had it from the lab, and they evolved it to actually a product, and I'm very happy about that.
We're kind of running out of time, but I know we have several people from School of Medicine here, and I'm wondering if I can get someone to kind of talk a little bit of or point our two speakers to who they might be able to connect with regarding an initial conversation for clinical trials or small testing.
Yeah, I think we already got one at the chat.
I think Ted just turned on his camera, so he probably wants to say something.
I have to unmute. Yeah, I just sent a direct message to both Professors Gansu-Burke and Vega about that. I'm Associate Dean for Clinical and Translational Research. I'm also the Director of the Clinical Translational Science Center. So as with Dr. Izaroff, I think there's a wealth of opportunity over on the side of the causeway for collaborations, and I just need to know a little bit more about what the type of collaborations you're interested in. They were great talks. Thank you very much for one thing. And especially with, on the side, we have Aggie Square going to be starting to be occupied within the next year or so, which is a public-private partnership sort of translational hub for us. And so a lot of people from engineering are going to be out here with a focus on neuroengineering and tissue engineering. But I think the type of work that you described would be fascinating to try to find partners out here. So I sent my email, I think, in the chat, but then I don't see it knows me and where to find me. So hope to set up something to meet. I think Dr. Izaroff is just offering her collaborations as well. But I think, there are a lot of to even just analyzing prosthetics and movement and things. You may or may not know there's a very good prosthetics group that is in the College of Engineering and a great a new rehab hospital here. So I was just thinking about the fabrics and the sensors and things like that as a way to just analyze how our patients are getting through their stroke rehab or movement disorders or things like that. I think would be just something that, anyhow, lots of stuff to talk about. Is just trying to find the right focus and starting something as always. So thanks for your presentation.
Yeah, thank you for offering your contact information. I recently started collaborating with Jonathan Schofield on all the prosthetic, amazing prosthetic work that they're doing. Yeah, there are so many possibilities.
Yeah, thanks for sharing. I think that the Aggie Square is kind of like also a great possibility, and I was kind of taking a look of what's happening, but yeah, being involved, I think it makes perfectly sense too. Thank you so much, Ted.
Well, we are 3 minutes past our end time. I'm just going to ask the audience if you wouldn't mind turning on your camera so we can get like a quick snapshot of our audience. I want to thank again our two speakers. This was really interesting. I think all of us are walking away with a very interesting view of what technology is coming up, new reasons to get tattoos if we needed them. So that's great. And definitely I'm keeping my red lipstick just in case. I want to invite everyone to join us for our next Team Research Forum. The next one is scheduled for February 9th. We're going to have a showcase related to space technology and space exploration work on campus. And then I want to invite you to join us on February 23rd. We're going to have our colleagues from Federal Government Affairs, Phil Harmon from UC Office of the President, and our own Brandon Minto from UC Davis Federal Relations. And they're going to talk to us about the budget bill. And where is the budget bill? And where is it going? And what does that mean for our federal funding dollars for your research? So it's a great opportunity to learn a little bit about the process of how budget negotiations turn into actual NSF funding and what can you do to affect that process. So with that, thank you again to our speakers. Thank you to our audience, and have a wonderful weekend.